Welcome to the night before news for Chemistry Paper 1. It's important when you get into the exam room to check the tier and title of your paper before you start the exam. So for this mock, Chemistry Paper 2, if you are in sets 2, 3 or 4, you need Combined Science Trilogy, Chemistry Paper 2 Foundation. If you are in set 1, you need the Combined Science Trilogy Chemistry paper Higher. On all the papers there are a range of questions, from multiple choice tick box answers to fill in the blanks where blanks have been left in sentences for you to fill in, to short answer questions worth 2 to 3 marks, long answer questions which will either be 4 to 6 marks. Then you've got data and graph interpretation, and in one or more of your papers you will be asked to plot a graph. You'll also be asked to carry out calculations that are specific to that exam paper, and then you'll also be asked to carry out a percentage of maths on that exam paper. Again, they will ask you short answer questions in Chemistry Paper 2 that will require you to recall information and Tier 3 scientific words, things like hydrocarbons and the fact that they are molecules that are made up of only hydrogen and carbon atoms, and then that there are different types of hydrocarbon. So for example, alkanes that are saturated hydrocarbons, they're holding as much hydrogen as possible because they have a single carbon to carbon bond in all of their carbons, and alkenes, which are unsaturated hydrocarbons, which are distinctive by the fact they have a double bond between some of their carbon atoms. Then long answer questions, 6 mark questions, are going to centre probably around scientific practicals that we've done, so the required practicals. The key one in Chemistry 2 is rates of chemical reaction, so they will give you an equation which will show reactants and products, and you need to look carefully at the products and see what is being produced in terms of the states of matter. So if you have a gas being produced, so if you took magnesium ribbon and acid and you got hydrogen gas produced, you could use an experiment to collect the gas being produced in a syringe or a measuring cylinder and record the volume of gas that was being produced every 10 seconds or 20 seconds, and then use that to plot a graph to calculate the rate at which the reaction was taking place. If one of the products was a solid that didn't dissolve in the solution, then you would use the disappearing cross method. That's where you take your 2 reactants in a conical flask and place them over a cross you've drawn on some white paper, and then you time how long it takes for the cross to disappear. The faster the cross disappears, the faster the solid product was being generated. And then command words in this are the same as all science exams, so describe, explain and evaluate. So describe questions will usually centre around data and graphs, and you just need to describe the pattern in the graph, that it increases from X to Y and then stays the same or decreases. So you're literally stating any trends or patterns in the data. Explanation questions require you to apply scientific knowledge. So for example, if we change the temperature of a chemical reaction, the rate of the reaction increases. Well, why does that happen? That's because when you increase the temperature, you give the particles in your reactants more kinetic energy. If they have more kinetic energy, then they're going to collide with one another more frequently and with enough energy to react, and that means that the product will be formed at a much faster rate. And then evaluation questions in this paper would generally centre around evaluating a method. So they might give you a method which has some errors in it and ask you to comment on how you may improve that method. So you need to go through it, think about what they're doing and their practical technique, identify the errors and then offer some suggestions to improve those. Again, identifying the key variables in any experiment in Chemistry Paper 2 is really important to understand, to be able to identify. So the independent variable in any experiment is the one that you decide to change, the thing that you are investigating. So you might decide to change the temperature of a solution, the concentration of the solution, the pH of the solution, or the surface area of one of your reactants. Now the dependent variable is the one that is going to change based on what you do with your independent variable. So it's the thing that we record or we measure in the experiment. So that's going to generally be gas volumes being produced, colour changes, temperature changes, things like that. And then the control variables are any other variable that could affect your dependent variable but that you are not investigating. So if you decide to investigate how the change in temperature affects the rate of a reaction, then you need to keep the volumes and concentrations of your reactants the same, or the masses the same. So we only allow one variable to change in our experiment. Graphs again. So in chemistry paper 2 you will definitely get some graphs, and you always need to make sure you know what the small divisions are equal to on both axes. So the best way to do that is to look at what one unit division is. So that is on the y-axis here, we're going up in ones. The intervals are 1, aren't they? 1, 2, 3, 4, 5, 6. And on the x-axis we're going up in tens. So they're our intervals. So you take your interval and divide it by the total number of squares that make up that interval. So on the y-axis here, our interval is 1 and it's made up of 5 squares. So you would do 1 milligram divided by 5. That gives a value of 0.2 milligrams for each small square on our y-axis. They'll also ask you to calculate rates. So if you get a straight line like this, then it's quite simple. You work out the change in y and the change in x, and to work out the rate, it's always going to be the mass or the volume of whatever's being produced divided by time, because that's what a rate is, something divided by time. So you literally do the change in y divided by the change in x. So the mass of copper divided by the time in minutes, and that would give you a unit of milligrams per minute in this instance. Finally, the maths. So they might ask you to round to a certain number of significant figures. So here we've got 1.46 and they want it to 2 significant figures. So the first 2 values that occur. So we look at the 4 here, and because that's lower than 5, we're going to round it down to 1.3. They'll also ask you to look at standard form or give answers in standard form. So here we've got 2 examples. 0.0021, that would be 2.1 times 10 to the minus 3, because if we move the decimal place 3 places to the right, it becomes 2.1. And then the second example would be 1.5 times 10 to the 6, because if we move the decimal place to the right 6 times, we get the value that we've got there. Units of volume, again, decimeters cubed is the standard unit for volume in chemistry. So there are 1,000 centimeters cubed in 1 decimeter cubed. So to convert that, you go from centimeters cubed to decimeters cubed, you would divide by 1,000, and from decimeters cubed to centimeters cubed, you would need to multiply by 1,000. Calculating mean averages, again, really important in all of our science papers. So here we've got 3 repeats of an experiment. We've got 23, 25 and 22. The first thing you should look for is any anomalous results. Those are results that are significantly different from the others. Here we don't have any that are significantly different, so we can use all 3 of them to calculate our mean. So remember, you need to add the values together to get the sum of those values, and then divide that by the number of repeats, which is 3 in this case, and the answer would be 23.3. But we do have to give our mean as 23, because you have to give your mean average to the same number of significant figures as the recordings that were made.